lesson is about simplifying expressions and keeping my models. And you're going to need compound angles and double angles and the square identity. So all of these formulas you must know for today's lesson.
It's not zooming nicely.
You're on video. Alright. The first example, these three examples are on your notes, but you have to take extra notes, and I'm going to give you alternative ways to answer the questions, which you can also jot down. When you get a complex expression like this, you should have two aims. The first one is to get rid of the negative angles. Are there any negative angles? No. The second aim is to make sure that all the angles are acute. So let's look at our first step. 35 and 35 is smaller than 90, so I'm fine with that. 225 can be rewritten as tan 180 plus 45. Reduction formulas. 200 is 180 plus 20. Now you look in which quadrant they lie. This one is in the second quadrant, and third quadrant, and tan is positive. The next one is also in the third quadrant, and cos is negative. No. Okay, I see that I have a special angle there, so you have to draw your triangle to show the marker that you know it's a special angle and how to use that. Now, from here on, you can go both ways. Either the one in your notes, and I'll come to the second method later. I see that cos 20 can be rewritten as sine 70. So I'm going to use the co-functions. Why? Because 70 is double 35. Okay, so I'm working towards something. Double angles. Then you change the sine 70 into sine 235. Expand, and then they can cancel out. And you are left with negative a half. Or you can do it this way. I see that sine 35 cos 35, it looks similar to 2 sine 35 cos 35. That 2 is not there. So I write the 2, but I immediately have to cancel the 2 as well. So this part is actually sine 235 by divide by 2. Are you with me? Okay. So I'm going to write that part as the numerator. Divide by negative cos. Divide by negative cos. Now you're in grade 4. When you divide two fractions, the divide becomes a multiply, and you flip that second part. Now again, I see that I have the 70 and the 20. degree. They are co-functions. So I turn either the sine or the cos into the other one. Now I have sine 70 over sine 70, and it will be negative a half. Are you all with me?
Yes.
The next example, we have two fractions that we have to subtract. Therefore, you get the LCM, sine 12, cos 12. So I multiply the first term with the cos 12 and the second term with the sine 12 and put it on one LCM. Then this reminds me of compound angle sine. So it's 36 minus 12. Which is 24 degrees. Okay, you have to put on your glasses, your math glasses. 12, 12, 24. Can you see these two are half of 24? So I can turn the 24 into 2 times 12. Expand that, and then you can cancel out, and your answer is 2. Okay, another method. Yep. Another method is to rewrite the bottom part as I explained in the previous example as sine 24 over 2. Again, I have a fraction divide by a fraction. Turn the divide into multiply and flip the last part. Cancel out and you get 2. So this just shows you that there are many ways to do a sum. One way is not always the correct way, the only way. And in the memos for tests and exams, we have to supply all the possible ways in the memo in order to mark your work. Right. Are there any questions in this example? The last example. I say rewrite sine 3 alpha in terms of sine alpha. That means that my answer must only have sine alphas. No coses, no tans. Right. So let's start with sine 3 alpha. You can expand that into 2 alpha plus 1 alpha. It's a compound angle. And now I see that I have 2 double angles. So expand this one and that one. But the cos double has 3 formula. Which one will I use? 1 minus 2 sine squared. Why? My answer must be in terms of sine. Right, good. Here I have a cos squared. Oops. So I have a problem here. What can I do with that cos squared? No.
You can write it as 1. You can write it as
1 minus sine squared.
I mean, sin squared.
Yep. The square identity.
That's
1 minus sine squared. I thought you were doing the cos one. Okay. So it's 1 minus sine squared, and now I only have sines. So I multiply out the bracket, add all the like terms, and then get my answer.
So in terms of just means, it was just somewhere in that answer I have what they said.
Yeah. Are there any questions?
Like when we see in terms of the new work, like new identities, are we done? Is it now we're just gonna do the proofs and apply them?
Now we're going to use the new identities into general solutions, graphs, etc., etc. Yeah.
What do you mean?
Okay. Your homework. Silence. Your homework for tomorrow is exercise 4, page 15, number 1 to 5. And now we have to mark all the previous ones. So we start at exercise 1. Yes. Yes.